So we're going to look at the equation for a circle here, and the equation of the circle is some sort of relationship between the x coordinates of the circle and the y coordinates of the circle, so that when we write this formula down, it can only be one unique circle, and it's clear which circle we have to draw, right? So we're going to start off with a circle and then try and look at the properties of a circle to see why we get the formula that we get. If we think about straight lines to begin with, we all know the relationship between any 2 points on the straight line is that the y coordinate at that point is equal to some constant multiplied by the x coordinate plus another constant. Okay, so we're all familiar with that, and we want to come up with a sort of analogous idea for circles. So the center of a circle, that doesn't look right. Doesn't have to be perfect, but just want it to look like it actually is the center, right? If we call this that point O, well, the origin will be O, we'll call it C. Then C has the coordinates, we'll say A, B. Okay, so at this point we've got A units on the x-axis and B units on the y-axis. Okay, and we can call the center AB no matter which circle we draw, but AB is at one particular point. Okay, now what do we know about a circle? We know that everywhere on the circle a line from the center to the circumference is R, and all of these lines are the same distance. Okay, so that's very useful because we must be able to use that in our relationship, since it's a constant in all circles that no matter which point on the circle, so whether we're at xy here, whether we're at an xy here, whether we're xy here, xy here, our distance from the center to that xy is the same. So what are we going to do? I want to rub out one of these radiuses just so that it's not in the way. Now we want to take a generic point xy, so this could be anywhere, but I'm just going to draw it here for the visual representation. And our radius is this red line here. Now we know the radius is constant, so if we want to find the distance of this radius, we'll use Pythagoras Theorem. So we create a right angle triangle, and what's nice here is this point's A, this is our x coordinate, so this line here, the distance is x minus A. Here this is our y coordinate up here, and this is our B, so that's y minus B. And by Pythagoras' theorem we know that x minus A all squared plus y minus B all squared is equal to r squared, alright, because this is a right angle triangle. So we can write out x minus A squared plus y minus B squared is equal to r squared. Okay, so that is our formula for the triangle. Given the constants A, B and R, then we have uniquely defined a circle where the center is AB and R is the radius. Hopefully you can see that if we move this point anywhere around the circle, we can still create that triangle. Say we put it here, we'll go for a different color, maybe a blue. Right, we can still create a triangle in the same way. have our okay. Here's our x coordinate again, x minus a, y minus b, and we get this. We square them and add them up, and we get r squared. Okay, so you can create these right-angled triangles all around the circle. So this holds for all x, y on the circle. All right. In the next video, we're going to look at maybe being given the equation of a circle in a slightly different form, and then trying to write it in this form, because this form is a nice form that gives us the center and the radius. We can just read it straight off, which is always nice. So we'll look at that in the next video. Hopefully you can understand where this formula comes from, because I believe you've seen it at GCSE, especially for circles centered at the origin. But this is a slightly more general formula, and hopefully you can understand where this comes from and why it defines a circle now. If you do have any questions on this, please be sure to let me know in the comments down below. But apart from that, that's it. If you did enjoy, please like and subscribe, and I hope to see you in the next video.